Hello guys, KNOCKCAT this side. So today we are here to solve today's GFG PODD and let us find the nth character. I hope you have already read the problem and have tried by yourself. So if you have not tried by yourself, I would suggest please do give a read to the problem by yourself. So we are given that we have a binary string S. A binary string is something which only contain characters 0 and 1. So we are given a binary string 0 and 1 and we have to perform R iterations on the string S. And the definition for those R iteration is like that if we have a 0 in our string, then we have to replace that 0 with 0, 1. And if we have a 1 in our string, then we have to replace it with 1, 0. And by doing so, after the whole R iteration we have performed, we have come up with a string, and in that string we need to tell the nth character, or we can say the nth index. So if I consider the very first case, it is like we are given with a string and we have two iterations to perform, and in each iteration one is becoming 1, 0. So this one would be 1, 0. Again this one would form in 1, 0. This 0 would be 0, 1, and again this 0 would be 0, 1. So at each iteration our length is getting doubled. At each iteration our length is getting doubled. After that we have our iteration got 1, and now we have one more iteration to perform. So now this one would be again 1, 0. This time this 0 would be 0, 1. This 1 would be 1, 0. This 0 will be 0, 1. Again this 0 would be 0, 1. This 1 would be 1, 0. This 0 would be 0, 1, and this 1 would be 1, 0. So now our iteration becomes 0. So this is a final string, and in this string we need to tell actually the nth character, and it is 0 based indexing. So nth is given as 3. So 0, 1, 2, 3, and we have 1 on the nth index. That is at 3, we 3th index we have third index we have 1. So we need to return 1. We need to return this one, which is actually s of n. But that is in this final string. Let's consider another case. Here we are given with a string 1010, and we have r iteration to perform. That is 1 here. And so if I formulate this 1 to 1, 0, this 0 to 0, 1, again 1, 0, and this 0, 1, iteration becomes 0. This would be the very final string. And now we have to tell the second character. So it is 0, 1, and 2. So we have 0, and you can see the answer is 0. So I hope the problem statement is clear to you. And let's come to the very brute force approach. And it goes the same, the knife approach, and it goes the same way that I was explaining. And I also hope that most of you have come with that approach and already know. But it's a good practice to start with the very nice solutions because it helps to make a good understanding for the people uh, for whom thinking the nice solution would be difficult in beginning. So let's say I have given the string 1100. So again, what can I do? Since at each step the length is getting 2, and if we have r iterations, it is very familiar that the string length at the end of the r iteration would be 2 raised to the power r minus 1. Some might be confused why the length will be 2r minus 1. You can clearly see this is of 8 length and this is of 16 length, and actually the length is 4. The length is 4, so it is 4 raised to the power 2. It is 4 raised to the power 2 because we have to perform two iterations, and at every index it is getting doubled. 8 to the 16. So that is how 16 came. But I will give you an intuitive way that why it actually we got the length should be like n raised to the power r. Why it's like that? N is 4 and 4 raised to the power r is 2, so 16. And here also if the I take this case and we have 4, and since iteration is r equals to 1, so 4 raised to the power 1 would be 4 only. Now let's come to think that how this is getting this. So like we can see that at each iteration the length is getting double. And why the length is getting double? Because for this one we have two choices. Like we don't have two choices, but let's assume in a way that this one is actually contributing in the next step two things, 1 and 0. So now assume for this one we have two choices, 1 and 0. Again for this one we have again two choices, 1 and 0. Although this is not choices, this is the iteration we need to perform. But let's consider in the form of like choices. For this one we have two choices. For this one again we have two choices. For this 0 again we have two choices, and for this 0 again we have two choices. So if we have two choices for each character, two choices for each character, the total number of ways in which this the total number of characters we have can have is would be 2 raised to the power n, 2 raised to the power n, 2 raised to the power n, and since n in this case is 4, so 2 raised to the power 4 is 16. Although we will not be using this, but I just want to tell, since we have two choices, the total length at the end will be 2 raised to the power 16, because at each step we have two choices for this. So let's move. So the brute force would be like simply 1100, and I will make a new string and new string, and for this new string I will, like, for everyone I will say append 10, for everyone I will say append 10, and for every 0 I will say append 01. So at the end my string would look like this, and since I have one more iteration to perform, I will iterate my this string, and I would say for every 1 do the same, make it 10, and for every 0 make it 01. And at the end when I have the final string, I can just say return my this string of character of n, so s of n. So I hope this thing is very clear. If I have to show the code to you, this is pretty straightforward solution. And what I have done here, we have r iteration. I take a new string str and assign s to it. And what I'm doing here, I have make a new string, and I am iterating this string, and I'm saying if at an index I have 0, append 01, else append 10. The same thing. At the end, I am assigning my here to new str. Why? Because next time I have to iterate, because I was iterating new str. So next time my new str should be the updated string. So I assign new str, and we actually don't need this step. We don't need this step because you can element this also, because every time I am declaring a new string. So actually we don't need this step. So after these all iteration, we would be having new str form, and next time new str would be a string. So I assign my here, which is the current string which I formed, to my new str. So at the end new str would be the updated string, and I need to return just nth character. So I hope the brute force approach is very clear to you. So now come to the optimized approach. I thought of a recursive way. So like that's why I was trying to formulate you that you have like two choices like for this every character. So like this is the same example that we have given 1100. This is actually the same example 1100. So let's say we we know at the end we have 2 raised to the power n minus 1. 2 raised to the power, sorry, uh, the end length we would be having 2 raised to the power n minus 1. We can clearly see, like, if I have a string length of 4 characters at the end, because at each step my we have two choices. So the total length of the string would be 2 raised to the power n. 2 raised to the power n minus 1, because 15 till 15. 2 raised to the power n minus 1, 2 raised to the power 4 is 16, minus 1 would be 15. What I want to say here, let's say you are at 1. So this 1 is now at 1, 0. For this one, this is the same thing. I just have opened how the string will look like. The intuition behind it's more, this is rather than intuition, it is a more type of observation, that let's say if I had to tell what is at my 14th character, like my 14th, because it will ask us the 14th index, though it is virtually here. We only have present with us with this. So this is how we have, like, in recursion we will formulate this string. So if we know we are at 14th index, we are at 14th index, so this 14th would have come from the previous row, from the previous row. This actually do not exist. This is our recursion only. Do not assume that this exists in real. This will be going in recursion. So 14th, its previous would be 7. Why? If you know what is a full binary tree, a full binary tree is a binary tree in which every node have two children. Every nodes have two children. Okay, and the last level have, and the leaf nodes have zero nodes. The leaf nodes has zero nodes. So this is actually, the recursion is also an example of a full binary tree. Full binary tree. So if for a binary tree, full binary tree, if I have a children at I, its parent would always get I by 2. For a child I, its parent is always get I by 2. So for 14, 14 would have definitely come from 7. 7, 7 by 2, the C value is 3. So it would be always be 3. Take any example. 6. 6 by 2. The parent of 6 is 3. 6 by 2. Let's take 10. The parent of 10 would be 10 by 2. 5. We have 5. For 5, 5 by 2 would be 2. 5 by 2, 2 to the 4. We will take seal value. Parent of 5 would be 2. So the motive behind getting to the parent. So can I actually, if I want to find what is the character at 13 index, can I ask to my parent, what is the character with you? What is the character with you? Can I ask my parent that what is the character with you? And 6. For 6, because this actually this also don't exist. So for this 6, can I ask what is the character with your parent? What is the character with your parent? 6 by 2 would be 3. So 6 would be asked its parent, what is the character with you? One more slight observation. We know for 0, 0 is formulating into 0 and 1. 0 is formulating into, our 0 is formulating into 0 and 1. And our 1 is formulating into 1 and 0. So the 0th, the odd position, sorry, this would be even. The even position for 0, the even position is 0. And for 0, the odd position is 1. Even, odd. Let me make it a bit here. Yeah. So for this 0, it will form 0 and 1. And for this 0, the even position is 0 and the odd position is 1. For this one, the even position is 1 and the odd position is 0. Just this is only observation. We can clearly see for 0, even position is 0 and 1. Why I'm saying this like that? For 0, it will come 0, 1. 0 is an even number. Like, it is even. For 1, 1 it is odd number. So at even position for 0 we have 0, and for 1 you can take any one. If I am at 2, so it will, like, because everyone has two possibilities, and like every time the length is getting doubled. So for this would be even only and odd only. Clearly even, odd, even, odd, even, odd, even, odd, even, odd, even, odd. So for 0, the even character is 0. For 1, the even character is 1. For 0, the odd character is 1. And for 1, the odd character is 0. So we are at here. Can 13 actually ask its parent what is the value with him? This time it don't know because this string do not exist. So it come at 6. Do 6 can ask its parent what is the value with you? Yes, this time, because it is a string given with us, I know the value with it is 0. I know. So it will return 0 from here. It will return 0 from here. And since it is 0, now what will it return? What will it return? Because when this 13 asks its parent, what is the value with you? At this time, the 0 is not here. So it has to ask his parent, okay, tell me, what is the value with you? So it returns 0. So now this 0, when this asks, so now this recursive call, this also don't know. So it asks its parent, and now it's know what is the value with me. So it has to formulate for this recursive call when this 13 asks, tell me the value with you. So now when it's come 0 from here, he knows that the value with me is 0. Don't be confused. This is an arbitrary. Here we know the value is 0, but in recursively we actually don't know. It has to go with its parent and ask him what is the value with you. So when 0 came here, now we have 0 here, and now he has to tell his child, okay, the value with me is 0. But we discuss here for 0 the odd case is 1, for 0 the odd case is 1, and for 0 the even case is 0. So, and now how will we, when we do 13 by 2 and we ask its parent, when we do 13 by 2 and we ask the parent, so 13 modulo of 2 actually is odd. So that means I am actually at odd index. 13 modulo 2 is 1. 13 is actually odd number. So I am at odd index. So I would be looking for odd answer. I would be looking at odd answer. 13 is at odd index. 13 is at odd index. So I would be looking for an odd answer. So when 0 came here, we will check what is the odd case for 0. For 0, the odd case is 1. And since for 0, the odd case is 1, we will get 1 from here. And now 1, we can just return the answer from here because we get to know what is here. I think it might be confusing for you for a bit, but before I go to the code, I would really want to see you on another case. How the recursion would actually working. This is whole recursion, and if someone struggles with recursion, for him or her, it's going to be tough. Not tough, a bit tricky, you can say. So, like, if I take an example, let's say I'm taking 9. Okay, so if I have 9, arbitrary 9 don't know what is it. So 9 will do a recursive call. So 9 has to know what is in its previous row. What is in its previous row. So 9 would have come to its previous row by actually doing 9 by 2, because 9 by 2 it's 5. 5 would be its parent in the previous row. And it is at R because this is the current. This is after R1 iteration. This is after R2 iteration. This is clear, I think. Yes, this is the current string we have. This is the R1 iteration and this is the R2 iteration. Now, so I would be calling my recursion like with R2, and I am looking for an nth character, which would be 13. Okay, 13 would ask its parent. So 13 would have asked, okay, my parent, tell me, let me make it a bit smaller and let me put it here. Okay, 13 would ask, 13 would ask the previous row, that would be R1, and it will actually call R1 with 13 by 2, 13 by 2. That he will ask its parent. He will ask its parent again from here, from here, this R1, this R1 would come to current string. This R1 would have been come to current string, and 13 by 2 is nothing but 6, and it has asked its parent 6 by 2, which is 3, and 3 is a part of this string. It has to be because we have n length string already. So from here I know, from here he knows the third character is 0. So it would have written 0 from here, 0 from here. Now, since I get the answer from here, what I will return here, what I will return here, for this I have to check that if 13 was odd or even. Because if 13 was odd, then I have to return odd index. So I would have to check, okay, if I'm just writing odd case, okay. If it is odd, then for odd case, if the character returned was 0, then return 1. Because for 0, we have 0, 1, even, odd. And if it is 1, return 0. I think this might not be clear to you for now, but just assume this was the odd case. So if 0 was written from here, and since I'm looking for the odd case, So if we got 0, for 0 the odd case is 1. If we got 1, if we got 1, for 1 the odd case is 0. For 1 the odd case is 0. So this is the odd case. Okay. So it has returned 0 in this case. Okay. And since for 0 the odd case is 1, so actually this will also return 1. This will also return 1. This will also return 1. So we got the answer. So 1 would be our answer, and this is actually the answer. Let me now consider, and this was the odd case. Let me now consider the even case. Let me now consider the even case. Uh, Let me now consider the even case. So we take 13. 13 because 13 is odd. That means I'm looking for odd. And recursively, before returning, I have to check it was odd case or even case. Here it is not the case. This is the base case because we are at the current string. When you look the code, you will get to understand. Here just look how the recursion would have been working. So if I would have add 10, so I know R2 was the iteration at the end iteration, and I have 10. I need to find for 10. And this R2 have call the recursion for okay the previous row, but actually don't exist. Which actually don't exist. We only exist with one. So it will ask, okay, R1, tell me 10 by 2 is 5. My parent would get 5. So R1, tell me your fifth character. Eventually, this fifth character, it also don't know. So it will ask, here we know. I'm again telling, here we know, but recursion don't know because we only have this thing. It will go to current string because before R1, we have only current string. It will go to R1 and it will ask, current 5 by 2 is 3. 5 by 2 is 3. Yeah. Okay. 5 by 2. Sorry, 5 by 2 is 2. That I was thinking that 5 by 2 is actually 2. We are taking seal value. Okay. We are taking seal value. 5 by 2 is 2. Okay. 2. So now for current, I know that 2 character, it is 0. That is, it has written 0 from here again. It has done 0 from here again. Now, this 5. This 5 is again odd. This 5 is again odd. This is the same exactly. This is come to the same. So 5 is again odd because 5 modulo 2 is 1. So it would have said, okay, tell me, what is, since it was odd case, so for 0 the odd case, I've already discussed, for 0 the odd case is, for 0 the odd case is 1. So from here also, we get to return 1. And so this is the answer. I think this is clear. I want to take the even case, but I'm thinking, is there any even case? Okay, for this 8, there is a even case. Okay, for this 8. Okay, I'm at R2 with 8. I'm at R2 with 8. I asked R1, the previous row, tell me my parent. My parent will tell me what is the value at it. Value at the parent. 8 by 2 is 4. 4. 4 will ask its parent. 4 will ask its parent, that is actually current. 4 by 2 is 2. 4 by 2 is 2. So current 2 no, I have 0. It will say, okay, I have 0. Now 4 by 4 modulo 2 is 0. 4 is the even case. 4 is the even case. It has to return to it. It has to return to it, and 4 is an even case. And since 4 is at even index, 4 is at even index here. 4 is at even index. So for this, he knows 8. 4 is at even index. So that means 8 would have come even. So 4 will say, okay, I'm at even. And it's even character. And since I have got 0, I have got 0, I have got 0. So it will tell what is the even case for 0. What is the even case for 0? For 0, the even case is 0 and 1. This is the even case. So it will return 0. And hence we got the answer as 0. So now let's come to the pseudocode. So actually, let's say I'm at a helper function where I have my string, str, and this is like the number of iteration I have. Let's say it is r, and let's say I am find the nth index. So the base case would always be that if I am at the r equals to 0, that's 0th iteration, that is our current part because 0 iteration, then I just have to return, because we have our string, I just have to return current of n. Sorry, it is not current. I just have to I just have to return my str of n, my str of n. That's it. And now I need to find the character at there. So the character would be ch, and it will ask its parent. It will ask its parent. I will clear your recursion if you will stay down to the video for 5 more minutes. Ch is equals to, it will call its helper. I know the writing, it's not very good. It will say, I'm writing only help. Okay, let's write for you only helper. It will ask, okay, str, same we will pass. And for r, we know I want to know from the previous row because parent is in previous row, and I ask my parent. I ask my parent. So now my parent would have written what is the character with its and its parent. So here, though I have to actually check those two cases, that if this n modulo 2 and 1, I know you know this is the odd case, actually odd case. You must be familiar with n and 2. If not, it is actually equivalent to n mod 2 equals to 1. So if it is odd, then there are those cases. Then there would be some cases I have already tell you. And if it else, it would be two cases. The two cases would be, if we have n and we have 0th character here, then for 0, the odd part would be always 1, 1, 0, 1. And if it is 0, or if it is 1, then for 1 also the odd part is, for 1 the odd part is 0. And here, if the character returned is n and 1, if the character return was 0, here I was looking for even case. Even case for 0, the even case is 0. And for 1, if the character return was 1, for 1, the even case is 0. So we have written 1. This is the step you might be feeling that how it's no. Actually, when I call the recursion from 8, just for 5 more minutes. When I call the recursion for 8 for R2, so I call the recursion for n by 2. So R1, because previous one is R minus 1, so R1. 8 by 2 would be 4. Okay, it is actually calling at 4. 4. So now when it's again came to the recursion, again it came to this recursion. And since this also don't know what is my character at, because R has not become 0 till now. So it again asks its parent. This line will again execute it. It will come to R0, that is actually current only, and 4 by 2 is 2 at 2. Now R is 0 actually. R minus 1, it is R1, R0, this is actually 0. For 0, str of 2, it will return some character. And when some character will return, this recursive call will end. This recursive call will end. And when this recursive call will end, it will actually ask what was the character returned. So this ch would be having that character. This ch would be having that character that has been written from here. So it will check if my n was odd. That means if my n was odd, then if the character, because it will check now, if I got from here, I got from 0, and the n which I am at current was odd. So for what is the odd case for this 0? Eventually this is the case. When I got the character for the recursive call, I would be checking the n with which I have called, it is even or odd. Because if it is even, then for I will look for even case, and if it is odd, I will look for odd case. So here, according to the code, we have 8. So 8 is actually even. So I got to the even case. So I said even case, if the character written here from 0 was 0. If the character written here from 0, then give me 0, or otherwise give me 1 if it was 1. So let me check what was current of 2. Uh, let me check what was. Okay, no worries. Current of 2 is 0. Current of 2 is 0. So that means from here we have actually got 0. We have got 0. Now, since we got 0 and 8 is even. So for 0, we got 0. For 0, the even case is 0. So it will actually return 0. Here, from here we got 0. And after this recursive call, it will also return 0. It will also return 0. So the previous call So this is the previous call. So this was the previous call, and 1 minute. So from here we have got the answer for this, actually the outer call, because for this case got here, and the other call we got, it has written something zero to this. So for this the answer we got actually zero here. I know it might be now it would have been confused, so I think the video would might got longer, but I think you might be not able to understand. So like when I ask for the character here, at this point I don't know the character, so I call the recursive call. I do the recursive call. So it again do the from this 8. It come to this call. It come to this call. Again, I don't know. So it would have do again the call for current. And when the call for current is made, when the call for current is made, this current, then if the call for current is made, this time I know the answer. So for this zero I have written. So I need to tell the answer for this case now. So for this case, this was the recursive call. From here to this, I have now get zero. And for this zero case, now from this, I will get the answer for this previous recursive call. So it will turn zero. And the previous recursive call was nothing. I was looking for R2, and the index I want to find was 8. So this recursion got over. And this is this is all the recursion. If you are getting difficulty to watch the video from where I was actually starting, where I was actually explaining this part, that how the recursion call is end. This I write because first the answer for this would be calculated, and on the basis of this, if it is was odd case, even case, to this recursive call the answer would be written. So I hope this thing is clear to you now. So if I come to the code, can I able to retrieve it? So I have done actually the same thing. For this 0, we have even case as 0 and odd case as 1. For this 1, even case is 0, odd case. I call the recursion, same thing. If r is equals to 0, I know return the s of n, because this time I would be at the current one that I was explaining, the last row to which we have access. Then I ask, okay, if that's not the case, ask where parent the character with it. Eventually, if its parent also don't know the character, it will again call the recursion. It will again call the recursion. And that what I was actually telling here. This will not go beyond. From here, when I came here, this also don't know the character with itself, and that's why it's again called to its parent. And at this case, the base case got hit. So at a time, base case will be hitting s of n, and then on the basis of s of n, if it is the odd case and if the return character was 0, then for 0 the even case is, then for 0 the odd case is 1, and for 0, and if the character was written was 1, for 1 the odd case is 0, we have written 0. Otherwise, if it was an even case, then if we get 0 from here, we will return 0. And if 1 was written, so for even, we got 1. And that is how the whole recursion will work. And I hope this is now clear to you. This is entirely I have solved using recursion. And if you are struggling, this means you don't have a proper grasp over recursion. I tried my best to understand this. Now I will come to the time complexity. So time complexity would be actually order of R only. Why? Because every time you see that we are just calling to its parent, our iterations we are doing. Okay. If you don't know, ask your parents at r minus 1, at n by 2, and r minus 1. Why n by 2? Because in a full binary tree, if we are at I index, its parent is always at I by 2. Okay. So r will definitely come to 0. And this n by 2 operation, we don't have any uh, in this time complexity, n has actually don't have uh, any significance, because n by 2 actually is n by 2 is actually the arbitrary index we are looking for till we reach to a string to which we already know. And on the basis of this, we are circulating answer to here, and on the basis of this, we are actually circulating answer to there. So overall, we will run for the r iteration, r, and n by 2 at the next step would be here, and n by 2. So in order r, n is actually reducing by log 2. But yes, we know n by 2 is actually coming with log 2, it will actually our n will form it from in log 2 iterations. But more familiar, we don't consider about n. Actually, we are looking for r iterations. That if I am at R2, tell me with R1. R1 tell me with R2. And is actually formatting what would the index for this character would be based on the index of this character, and from here what we will get. So overall it would be order of R. But the space complexity, the recursion stack space our code will take, that will also order of R, because we are at worst we are doing R iterations, that if R is 15, I will eventually come down to 0. So these 15 iterations were in my stack. So time complexity, order of R for this in this case, because we are actually looking going till R iteration, and the space complexity, this is the stack complexity, and this is also order of R. So I hope I was able to explain you the intuition behind it, the recursive tree, how all things have been working, how this 8 would have turned to 0, and how this 0 will formulate answer to this one on the basis of even and odd cases. And I try my best to explain you the recursive, but now if I look at it, I know it's become unclear, and it's become because a lot of things I have wrote it down here. So if you have any difficulty, I will say like, do watch this recursive part again, and you will get the clarity again. So I hope I was able to tell you, explain you the solution. If you get to solve this, there is one more problem on lead code, and I think that was is care symbol in grammar. The problem statement is very similar to it, but there the observation you need to make is different. So I will definitely see you if you have solved this, solve that problem also. Kth symbol in the grammar. So that's all. Not at this side.